We're going to start off in accordance with the agenda here. John will kind of lead a panel discussion on corrosion issues, and you got it, John.
Okay. Well, welcome to the 37th annual Seaplane Safety Seminar.
John, if you would, I think in order for you to pick it up, your microphone going to get him without using that?
It's tougher.
Yeah, please use the microphone.
As I start, can you hear me?
No.
How about now?
Yeah.
Okay. If it squeals, I'll put it down. Welcome to the 37th annual Seaplane Safety Seminar. These things have been, the very first one was actually held in this building before they were an annual thing. J5 came and we filled the hangar, so it was fun. And we decided to do it as a continuing thing. So this is the 37th. The only time we haven't done them is during COVID, of course. But it's fun. It's great to see old friends and make new ones. There are several organizations that are involved. This is Safety Foundation, the Seaplane Pilots Association. Join one or the other or both because in numbers there's strength. The patches that you got today are a donation from Northern Lights Avionics, Pratt Aviation, and the Seaplane Pilots Association. So wear them well. We're going to talk today a little bit about seaplane corrosion. We've had some events that have taken place recently that are kind of scary. So I'll let Millicent talk a little bit about some of the things that have happened in the past and kind of what drove today's presentation. And today we'll be able to look at it from the engineering standpoint. I'll talk to it from the maintenance standpoint and the interrelationship between the people that own the airplanes and fly them and the mechanical trades.
Good morning, everyone. My name is Millicent. I'm an NTSB investigator. I've been with the board for about 10 years, and currently I've been out on maternity leave for the past few months, so officially I'll be back in the office next month. And right now with the board has been very busy, more than usual, with the large amount of big accidents that we've seen, as well as we transition into the new administration and new policies that we've seen coming out. But safety is always our main goal, and we love to support any effort that we can and connect with pilots. And talking about the float issue, we saw 3 accidents over the past few years. 2 resulted in fatalities. Luckily, the other one, the occupants were able to get out uninjured. But all involving floats. 2 were heavily corroded, and they resulted in the airplane cartwheeling across the water. And unfortunately, that you end up upside down in the water, and that's a tough position to be in. And certainly one we want to avoid. So what we've seen was there was a lot of floats that are getting older, and we were seeing some maintenance practices that we thought could be better. But there wasn't a lot of guidance out there, so we've all been working together to put together a checklist for your floats, best maintenance practices, and while it's not out yet, the board is going to be putting out a safety alert later this summer. I was hoping to unveil it here, but like I said, with the busiest quarter we've had at the board, that's been delayed. So look for it this summer. You'll see a safety alert on float maintenance and some safety improvements we can make in that area.
One of the things that all of us need to understand is that there are problems on airplanes. You know, they're complex machines, but you can't fix it if you don't find it. And there are a lot of ways to get into that. But let's talk a little bit about the physics of it. And I think Dave can shed a great deal of light on that.
Yeah, maybe if we could turn off the other mics, we might not get as much feedback, but talking about physics. I'd like to talk first a little bit about some of the practical stuff. I'll get into a little bit of the theory and then swing that back to practice again. So we are having some corrosion problems, and we also ended up having accidental damage problems, especially on the bottoms of the floats where somebody has, beached an airplane and you get scratches, gouges, et cetera, on the bottoms of the floats. So how many of you, when you do pre-flight on an airplane, put on a scuba mask and inspect the bottom? Not a whole lot. Okay, we're getting a lot more back all of a sudden for some reasons. Okay, so the bottoms of the floats are where we tend to get a lot of issues. Now, there are a couple of reasons for that. Now, when you look at how aluminum alloys are, where aluminum is on the periodic table and some of the basic electrochemistry of aluminum, aluminum is a very active element. It's on the periodic table, in that group with oxygen, carbon, and some of those other elements where it likes to exchange its electrons with anything it can find. And that includes oxygen. And it will form oxides very readily. And so if you feel like if you're in your shop and you grab a piece of aluminum, polish it up nicely and then put it outside for a little while and see how long it takes for that shiny surface to turn dull. What's happening when it turns dull, which will happen in a humid environment very quickly, it's about a day or two outside in the rain, and you won't be able to see yourself in that surface anymore. What's happening is a passive layer of oxide is forming on top of the surface of the element. That's aluminum oxide. There are two common oxides of aluminum, Al2O3 or Al3O2. Now, in the presence of a lot of oxygen, we tend to find Al2O3, which has got more oxygen and less aluminum, because that's energetically more favorable from a chemical reaction standpoint. The other reaction occurs when you're in a crevice, like when you have a rivet that is bucked into a hole. How many of you have noticed the black streaks coming out of rivet holes sometimes when you get a loose rivet? People call them smoking rivets. What that black material is the oxygen-starved version of the oxide. It's Al3O2, more aluminum, less oxygen. And from an energy standpoint, that is why it happens in those crevices, because there's less free oxygen available dissolved in the water. Now, we've had a little bit of at least anecdotal evidence that a lot of local mechanics that they could have been seeing corrosion problems on floats. And so we were saying, well, it seems anecdotally like something has changed. And so thanks to Mary and a couple of other people that were willing and able to find some water chemistry data from the state, we did get some chemistry out of Lake Hood. And there are a couple of, now, the frequency of the measurements is not what we would like to be able to have to be able to really science it out. But one of the things we are seeing is this. Now, this gives you, and for those of you who can't read the label, it's salt, sodium chloride. And what it does in a chemical reaction is it lowers the electrical resistance of the fluid. And in addition, the chloride ion tends to destabilize this passive layer, that little layer of aluminum oxide that forms on the surface. Now, when you have a float and you beach it, what you do is you sort of scrape off some of that passive layer, because it's not all that strong. And it's basic. If you use aluminum oxide sandpaper, that's chemically what you have in an oxide. And so it sort of sands off when you abrade it and when the airplane slides through the water, and then it reforms. And then it gets abraded and then it reforms. And then as that happens, you're losing material. And the bottom of your float gets thinner and thinner and thinner. And eventually you start to get little pinholes, and then it starts to leak. So, the floats have got a specific life, and the life will depend an awful lot on the salt concentration. How much of this is in solution? Because the lower the electrical resistance, the more electrical energy or electrons are able to go from the anode to cathode. And that is what drives corrosion. Now, what can you do about it? So, I know most of you are probably not going to put on your scuba gear and inspect your floats underneath on annual, and that's just not a reasonable thing to do. However, when you take the floats out for annual, you really need to take a really good look at the floats. And if you're quite a few years old, it might be good to actually see how thick the metal is anymore, because you're probably losing some surface. Now, it's not very easy to actually measure the thickness of the bottom of the float, and most of the ways you do it destructively, like drilling a hole and then miking a hole and then putting a rivet into it, are difficult to do and are probably not desirable for a lot of other reasons. There are ultrasonic ways to measure this, but then you gotta have the equipment to be able to do it. So mostly you're probably doing it relatively qualified or qualitatively by inspecting the surfaces. Now, a couple of things you can do on pre-flight. So when you get to your airplane and you pump out your floats, how many of you come back around later and pump out the compartments that generated a lot of water? Good. Because it's, if you walk around your airplane, so what I would recommend you do is when you get to the airplane, before you get all your gear, do your refueling, pump out your floats, and know which compartments are generating water. And then come back around after you're done with everything, maybe put your pump on the pilot seat so you don't forget, and then check the floats that you generated some water. The other thing is be a little suspicious if you have a compartment that never generates any water, because the hose may not be connected to the pump out. And you can pump all you want, and if the hose is not connected to the pump out, and polymers will age over time. The polymer materials, outgas out of the material, and they get hard and brittle, and they start to crack. And even if they're not completely severed, if you have a large enough crack that you're not able to, you just start sucking air through the crack, and you're not really getting water out. So if you pump and initially you get a lot of mixture of air and water, and you're not getting a good solid pull, that may be an indication that you got a crack or a leak in that hose that goes down to the bottom of the float. I also want to bring up one thing that has happened in a couple of accidents in the past. Now, this is looking back a lot of years, but when you step on the float, what happens to the airplane? It's going to roll, yeah. Now, if you have water in your fuel tanks, and you sunk the tank, where is the water going to go?
Lowest part.
Lowest part. And that just went outward. And where your sump is on the inward part. Now, so if you have a lot of water in there, you may get a little bit out of there, but you could be missing quite a bit. Now, float planes especially tend to be on the water, and it tends to be more humid, and there's more probability of generating more water due to condensation on the inside surfaces of the tank. Because we have vented tanks either through a vented cap or through a pressure, like the Cessna's we've got the forward-facing vent. And so you get water condensing on the inside that condenses down and then lowers into the bottom. That's one way we generate water in our fuel system. Now, the other way is a gasket along the cap. If you have like a 182 of certain years, they have what they call the death cap. That, you know, has a little recess that makes the upper surface nice and aerodynamically clean. But if you get a lot of water, it just tends to pull water up in that little pressed-in aluminum sheet metal thing, and then the water, if the drain is plugged, the water fills up and then drains into your fuel tank. On the Super Cubs, another place is that where the drain, or where the fuel filler cap is, if you have had somebody that has put the fuel hose on there and wrenched it back and forth a few times, right where that neck comes out of the welded tank, it gets bent back and forth again, you can get cracks around there, and then water from rain, et cetera, gets down there and leaks through that crack into the tank. So there are several ways that you can get fuel in through water into your fuel system, and it won't necessarily burn in your ignition. So from the gasket, keep the gasket good. Probably need to replace this about 5 to 10 years. The fuel lube compound is often a good thing to put on some of those gaskets so that they seal better. It also prevents the gasket from drying out, and they last longer. And it looks like but those are a couple of tips that I can give you on fuel tank maintenance. Now, the other thing that we're currently working on with the rest of the team is generating an annual inspection checklist for floats. Now, if you have a more modern set of floats, you probably have one that were generated by the float manufacturer. If you have really old floats that have been around for a long time, they probably didn't have one. And so getting a good annual inspection checklist is a good thing. Now, if you don't have one, we're trying to generate one based on all of the best practices, and we'll probably publish it through the Seaplane Pilots Association. If you want to, if your say your annual is up this month and we haven't published that yet, you can always take a look at one of the newer floats, like a Whip-Air float that has one, and the chances are that there's a lot of good spaces to look at. One of the other things you can do that helps you is get a zinc anode onto your float. They sacrifice to prevent corrosion on the rest of the float. They need to be electrically bonded to the substrate in order for that to work. So usually you want where you bond the zinc anode, a lot of times it's down on the heel, right after the step. But there are other places that are manufacturers that put them. When you put them on, a little bit of light abrading and then some electrolytic grease to make good electrical contact between the anode and the float. There's one other slight caution. Because of some environmental concerns, the marine industry has been moving away from zinc and moving towards some other alloys that are more aluminum and or other metals that are mixed into their zincs. If you take a voltmeter in salt water and compare the voltage generated between your anode and your float, what you want to have is as large a voltage difference between them as possible. Because then the anode that you bolted on there corrodes and your float does not. Because you can replace the anodes pretty quickly and easily, and some of the newer ones don't have as much voltage between the anode and the base float. So if you can get real zinc zinc anodes, they work better. Because we're trying to protect against aluminum, so if you hold an aluminum anode on an aluminum float, it's not going to do a whole lot because there's not a voltage potential between the anode and the cathode. So does that make sense? The other thing is if you're in saltwater, anything you can do to keep salt off of the rest of the airplane. Obviously, if you're floating in saltwater, there's not much you can do, but you can rinse the rest of the airplane with fresh water because this stuff is pretty evil for floats. And keep fresh water. Sometimes I do a little experiment that I take a zip cord kind of light and turn the light on by adding water, adding salt to water, to just illustrate that. But, okay.
Let me talk. Can you hear me now? Okay, let me talk a little bit about us. How many of you fly wheels in the winter and floats in the summer? When you put your floats up, what kind of inspection is done on the float that is analogous to the annually you do on your airplane? Think about that. And here you are, you're taking a major component of your airplane. You're going to do every landing you do is going to be off airport. So it's not a real smooth landing, although some of us are a little bit more rough on our landings than others. But the idea is that you haven't inspected your floats. I have a friend that brought his airplane up from California, Amtrak, on wheels, had a low strut, I loaned him a nitrogen cart, he serviced it, and I said, "You just came up, didn't you?" He says, "Yeah." I said, "Just put your floats on?" "Yep, sure did. And this is the final before I can go fly." I said, "Well, that's great, that's great. When did you have your annual done?" "Oh, we had it done last winter." "When did you have your annual done on the floats?" "Well, we're gonna do that when we take it back to California." The problems that we had, the ones that Millicent alluded to earlier, they would have found those problems had they looked at the floats before they went on the airplane, or at some point in time during the course of the year. A tip from the mechanical side is if you do that inspection in the fall when you take it off. Because what you don't want to do is to have the mechanic putting them on and the springs like, you got a real problem here we have to fix. Because he's buried, most everybody else is buried, and you want it in the water. So you kind of plan your maintenance on your floats. There's lots of opportunities to fix things, but you gotta find it first. We're at the point now on flat gear assessments where we pull the landing gear the first time I see the airplane, and do a non-destructive inspection, a diametric inspection on the gear castings. And we're finding a significant amount of problems. And that is not a quick process, but it's necessary. There's just something wrong about having a gear casting break. It generally causes a lot of consternation. You have a chance to talk to Millicent and her folks. Then your mechanics says there's some, So that's one of the things that I would highly recommend. Do all your float maintenance start in the fall. Guys like me will appreciate it. You'll appreciate it because in the spring you got almost new floats going in. Okay, I can talk for hours on the mechanical side of it, but I'm sure that some of the things that we talked about today have generated some questions. So if you have any questions, now's a good time to bring them up. Yes, sir.
So what do you think about Corrosion X? Does that do any good in the wings, and might it do some good in the floats?
Corrosion X is an interesting thing. I won't talk to the chemical properties of it, but let me ask you this. When you rivet two pieces together, what's the goal? Fasten them tight so that they don't move. And when you start putting Corrosion X on it or any of those sorts of things, you're lubricating that joint. Plus the fact if you ever have to get in there and do anything, that's an absolute horrible mess to deal
compounds are a little bit of a double-edged sword. And so I think you gotta use the right compound in the right location. Now, if you are dealing with a float that has a sealant between the surfaces, the corrosion act shouldn't be going inside that unless you didn't get the sealant done right. But John's right, they can create a bit of mess. Now, if you are in a blind area that you're not going to be in for a long time, like the inside of a control tube, the inside of a lift strip, they can extend the life of that from a corrosion standpoint quite substantially. They can be very beneficial to that. Now, in generally just sort of pulling the pin and throwing the can back and back of the airplane, that's probably not a very good thing to do because it sort of fogs the whole area and it can displace grease in rolling element bearings like ball bearings. It also can trap a lot of dust and fibrous debris. If you have a dog, like, you can probably judge the dog colors of the dogs I've got based on the color on my boot. But you see it collect a lot of stuff. And dust, dirt, debris, etc., and that can then cause water to get trapped. The other caution is, and if Gary is around, he could probably speak to it more, it's probably not a good idea to bathe electrical wiring bundles in things like corrosion acts. Because the wire bundle is intended to cool, and when you have current passing through it, the bundles do tend to heat up, and corrosion acts will not allow that to occur as much, and there is some flammability. The other thing about it, if you're dealing with steel structures that you are going to powder coat, most of those compounds, and they vary some between the compounds, they will start to break down at 200, 300 degrees Fahrenheit. They first start to get very liquid and they'll flow a lot, and so they tend to go to the lowest point. And then if you continue that, they start to essentially burn. And they'll consume the available oxygen inside there, and they become this sort of base, blackened junk, and they lose a lot of the corrosion inhibiting compounds. So if you're talking about an engine mount, for instance, or perhaps a lift strut, we really don't want to apply corrosion acts to the inside and then powder coat it, because the powder coating temperatures debate that the powder coating are higher than the corrosion acts and LPS3 and some of those other compounds can take. The Royal Australian Air Force did a pretty good study that compared a whole bunch of them in service with some of their military aircraft that were operating in coastal areas of Australia. And there are a bunch of different compounds out there. Some of them are more thick, more waxy, and tend to be more tenacious and will stay put. Other ones will wick into these faying surfaces more. So they have a place, but just an LPS bond is probably not the right thing to do. But there are times when they can really benefit you quite a lot. So that's a long-winded answer to that. Probably the best thing you can do is a really good primer. If you have the structure apart, like during maintenance, prime it, anodize it, a good epoxy-based, if you had zinc chromium primer, those work really well, but there's some other substitutes nowadays that work pretty well. And then potentially a top coat. And so that insulates the electrical surface and keeps this stuff away from the surface. Those are electrically disconnected. One other technical thing about corrosion, corrosion always requires an anode and a cathode. so like if you have stainless steel hardware, great, stainless steel won't corrode. What it does though is corrodes the piece next to it, it sacrifices to it. And so you have to sort of choose your poison. If you want to use like stainless steel hardware, you know, like access panel screws and stuff like that, they tend to corrode the holes that they go into. So the steel will be fine. Now, and some people would say, well, I'm not going to, I'm going to use stainless steel, but you know, because the stainless steel won't corrode, I'm not going to paint it. If you paint the surface of the stainless, it prevents the corrosion on the piece that it's up against. So it is beneficial to put, like for removable fasteners, to paint their heads. And sometimes that's an application where a little bit of a thicker water displacing corrosion prevented compound, when you put the screw in, actually can help you eliminate or reduce. You can't ever really stop corrosion unless you're in a vacuum of space. But you can slow it down, and preventing electrical connection between two components is one way to do that.
There's a study out right now that is beginning to draw some attention, and it deals with carbon fiber and aluminum. They're noticing some reaction between the two. So those of us that are dealing with composite floats, there's both metal and typically carbon fiber in those. So be aware, be cognizant. You're going to talk to, listen to it, understand what it's saying. There's a question back here.
You may just answer it. I'm just going to ask if there's anything, those of us who have moved on from aluminum to composite, is there anything in particular to watch out for? That's question one. And secondly, this, whatever's in the liquid water that turns our floats ugly, does it do anything other than make it ugly, or is there something to be concerned about and keep them clean for a reason other than cosmetic?
Yes.
Cleaning it would
We're in the process of doing some water analysis out there to see what's going on right now. Well, when I came up here and put my airplane in the water the first time I could, visibility was about an inch. It was terrible. And there were no weeds. It was an unfriendly environment. And part of that was the drainage from the de-icing fluids off of International Ramp. That's been fixed. That's separate. They're using a well or wells and streams to keep the water level out there. So there's some stuff there. We're looking at other things that may cause float corrosion and float issues for the metallic floats. But in terms of the plastic floats or the composite floats, again, that's going to be long term. It's going to be down buried in the composite material, and it's going to be hard to find and hard to see. So pay attention to your floats. If things don't look right, they probably aren't. Go with your first switch. Talk to the mechanic. Talk to the float manufacturer, because they're mostly all aware of this. Are dealing with it at their level.
I can comment a couple of things on composite floats. During winter storage, composite floats are more susceptible to freeze-thaw issues. So once you take your floats out in the fall, first get them as dry as you reasonably can. And then, if possible, store them in a protected area. If you can store them inside where it's where they stay dry, and it would be great if you can keep them warm so that they're not dropping below the freezing point. Because when you have trapped water, the composite materials are relatively resistant to water intrusion, but especially when you have, some floats have areas where you have foam inside the composite structure. So you have like 2 layers of fiberglass or carbon fiber, a layer of foam, and then another porosity can allow water to get down into that foam, and then when it freezes, it expands and you get freeze thaw damage to the float. So if you can keep it from freezing, that helps. If you keep it dry, that helps. But of course, it was pretty wet when it was sitting in the water over the summertime. So that's one thing from a prevention standpoint you can do in the storage. Now, if it has been sitting out for a long time and going freeze thaw, freeze thaw, freeze thaw, the chances are fairly good that there will be some damage. You can do tap testing on the sides, and by the way, a quarter is not heavy enough to really get you a good tap. You want to use something a little heavier than that. Like I've got a challenge coin that I use sometimes that is about the right weight. That gives you a good thump to be able to tell whether audibly whether you got a delamination. We have had a couple of problems with impact damage due to either hard landings or just impact with debris floating in the water that can fail the bottom lines in some floats. The other problems, especially as John mentioned, is carbon fiber. How many of you are old enough to remember carbon batteries? You know, before we had those new alkaline batteries and lithium batteries, we had carbon batteries. And the chemistry is very similar in a carbon battery to a carbon composite float up against your aluminum. And so the aluminum will sacrifice to the carbon. So when looking for hardware on a carbon composite float, stainless steels and titanium are preferred over definitely not aluminum rivets for a couple of reasons. First, when you squeeze a rivet, they expand, and that tends to give you little micro cracks in the composite around the rivet when you squeeze the rivet. And then the little bitty cracks that are around the hole, water gets in them and then freezes and then spreads the crack more and more and more, and that's a slow degradation mechanism in composites. So in general, don't use interference hit fasteners like rivets in composites. For the best corrosion, if a magnet sticks to it, then it's probably a martensitic stainless steel, not an austenitic stainless steel, and it's not going to be quite as corrosion resistant. It may be stronger, but there's always a little bit of a give and take between when you want good, do you want good corrosion resistance, or do you want high strength? And unfortunately, a lot of our traditional aluminum floats were designed by aircraft people that wanted lightweight and good structural performance, but were willing to sell you a new set of floats every 20 years. And so they chose alloys that were less corrosion resistant but stronger.
Is painted floats a significant attraction from the corrosion?
Yes, it is. The corrosion rate is proportional to the exposed surface area. So if you could completely encapsulate it in something that is non-electrically conductive, you won't get corrosion. Now, having said that, there are mechanisms where scratches, some people, you've seen the little worms that get underneath paint coatings. If you see those on an annual inspection, burst them, sand it out, repaint before it gets bad, because there's that is what they call full form corrosion. It gets underneath the paint layer, and then what will happen is the oxide, in order to form the oxide, you need to create oxygen, and if you don't have oxygen dissolved in the water, so this is one of the things we're measuring in Lakewood, the dissolved oxygen concentration fluctuates a lot. So if you have a lot of plants growing, plants create oxygen. That means there's oxygen dissolved in the water, and that means I don't need to break a water molecule to create an oxide, right? It's energetically easier to do. It creates less energy. Less energy means a faster corrosion rate. So underneath that little bit of bubbled up paint, you can't get oxygen there. And so what happens is you split a water molecule. When you split the water molecule, you get oxygen, and then you also get hydrogen. Now, in solution, does anybody remember their high school chemistry well enough to know what hydrogen in solution is? That's an acid. And if you have acid on your aluminum, it eats things up. So that progresses the chemical reaction further. So if you start seeing those little worms happening under your foot, get on it quickly. Because if you do that, then it's a lot cheaper long term. Because you don't have to fix bigger problems later.
So we've been putting antifreeze in aluminum floats and now aero sets for the last several years. Are there some thoughts about that in the
Yeah.
fall?
You're talking about the RV antifreeze.
The what?
The RV antifreeze.
Yeah.
In general, I think that helps prevent, especially preventing freeze-thaw action. Especially if it is the right grade, because they make it in different temperature limits. And so the idea is to get enough concentration to prevent freezing. And so you get it at minus 100, which will sustain a lot of dilution before it won't freeze anymore. And there are typically some anti-corrosion inhibiting compounds added to it as well. And so I think it does help.
Jamie?
We'll go on the back, Jim.
I'd like to hear from NTSB investigator Millicent regarding an accident that occurred, a real-life accident that occurred that could have been maybe prevented by a better pre-flight or something of that nature.
Unfortunately, you take your pick. There's several of them. The one fatality in Squinta, this was in 22, I believe, in the fall of 22. Those floats were so heavily corroded. The part that failed was about the size of a dinner plate. So when we look at accidents, landing gear accidents, on wheels, if your landing gear legs fails, you skid to a stop. Usually you're not hurt, just some damage to your airplane. If you're on floats and a dinner plate size opens up in the bottom of your float when you're landing or taking off, it's gonna probably tear up your airplane and likely you. In that case, it was fatal. Because like I mentioned earlier, you're upside down, underwater, you've got a head injury. The accidents that we see from float failures are much more catastrophic than a landing gear failure, just because of that. A flat tire isn't gonna hurt you much. There was the accident at Lake Hood. That was another float, a dinner plate size hole opened up in that float. Luckily, they were able to get out. Another accident, maintenance related, Fairbanks. The pilot was pinned and unable to get out. In that case, there was several things happening. Some understream cargo in the back. So when he did topple over, he wasn't able to get out because the cargo pinned him in. But as far as issues with the floats, there were holes that were open. They had some maintenance with the floats done when he bought them. New holes were drilled, the old holes weren't filled, so they were sitting really low in the water, filling up with water. He made one attempt to take off, went back and tried again, and there was just too much water. And we know there was maintenance done on floats, but there was nothing recorded, and nobody wanted to talk about it. So please pay attention to your floats. Take them to somebody who's willing to make the log entry, because they stand by their word. And look at them top to bottom, inside and out. And not just your floats, but if you're getting on someone else's airplane, make sure they looked at their floats. There's a lot of tips that we've talked about here, like pumping up the water, pumping it in if you're not getting any water. Making sure they're inspected, because like John mentioned, if you have your airplane looked at in the fall, when it's not on floats, they don't get inspected.
you sell your floats, get a new set, that history is lost. When I started to do logbooks a long time ago, the new manufacturers are now all doing logbooks because you have to keep track of that stuff. And it's a good place to document the inspection on it. That way, if you have your airplane done by one person, floats by another, floats on floats, the guy that does it can say, oh yeah, they've been inspected. And then when that happens, now you've got a complete history on it. And don't forget that when you pull the landing gear out, before you put the port jobs in, inspect the gaskets. It's a perfect time to open, you can see them. Most guys look at them and say, yep, they're there, stuff the port jobs in, and off you go. That doesn't do you any favors at all. We're doing NDIs on all of your assessments that we see for the first time and finding a significant number of cracked and corroded gear castings. Cheap and easy to fix, relatively so. It doesn't take a lot of aviation dollar units to do those, but it's time consuming. We did one airplane that was a couple $100 to do both of them. And it's an interesting process. If you're interested, let me know and I'll call you next time we find one. You can come see what we all have to do.
On the accident information, getting prepared for this talk, I asked one of our, well, I guess not mine anymore because I'm retired, but to pull some data overall in terms of the fatality ratios for float plane accidents versus land plane accidents. In Alaska, we tend to have about 9 accidents per fatal accident. So it's so we're getting about 11%, in stating it another way, it's about 11-12% of our land plane accidents include a fatality. For float planes, it's about 20%. So it is about almost double the chances of having a fatality if you have an accident on floats. And there's some things you can do, survival gear, survival training, so you know how to get out of your airplane, and think about the egress of the airplane prior to the accident. So, maybe back first.
pH level testing on the water on a regular basis, underwater cameras, and all these incidents with floats, there's no reason why we shouldn't have mandatory logbooks for floats. Accident prevention, number 1. Right?
I think all of us would agree, logbooks for floats are definitely a good thing to do. In today's regulatory environment, I don't think we're going to see a regulatory change in that, but I think that people can do it nonetheless, and I think it is absolutely a really good thing to do. It's also a good economic thing for you to do, because if I were going to buy a set of floats, having a thorough maintenance history on the float would definitely raise its value, in my opinion.
Float lockers that aren't well sealed are very dangerous. I've seen some that really don't have any seals and they just use a bungee that holds them down. A good friend of mine up at Lake Menchumina lost a son in a near drowning of a wife when a 206 turned over. It was rough water and he kept taking in water through his float lockers. And I've seen quite a few that aren't well sealed.
Yeah, the float lockers and also the access covers on top as well. Some of them are not very well sealed.
Sure.
And don't forget your plugs.
If you have float pump outs, every time a wave goes over those, you put a cup of water in your float. How many cups of water does it take to affect your takeoffs and landings?
Right.
And don't forget that if the bottom of the float opens up, dinner sized plate, that's like the wheels down landing. It's an instant over on your back.
Yeah.
patches on the bottoms of floats? You mentioned dinner side holes opening. Is that because patches are failing, or is that the float actually just corroding, collapsing?
The two that had those side holes were not patched. Excuse me, there were patches on the floats, but that's not where it failed. The one in Squinton had a patch on a patch. There was, I can't believe they floated as far as they did. And I think that there's so many more out there that are like that. When we went to other maintenance operators, they said they've seen more floats been coming in, which is great. I love that people are getting inspected. But they also said that they're not working on some of them because they're just too far gone. So they said they've got to be scrapped. So I really hate to think that floats are getting that bad, because it is so dangerous. And I hope we don't see it again.
One of the things to remember is that the floats will talk to you just like your airplane does. If you have a compartment that's got patches on it, it's starting to leak, you're starting to bump it more, pull it out of the water and take a look. It's happening for a reason.
And the patches do slow you down and take off a little bit. And especially if you're leaking, because you're gonna get more weight, and that's going to slow you down and take off. And so you can try and attempt to drive through the trees on the end of the dock or on the end of the lake, because you're not able to get off. From an operational standpoint, having a really well thought out go no-go point on takeoff is really good. It's a very important best practice, because if you're overweight for some reason, either because your floats are full of water or because you overloaded the airplane inadvertently. We get a lot of float plane accidents that are overloaded because the airplane, gains weight when you're put floats on to begin with.